share my screen. So let's see. Share the screen. Okay, so now you should be able to see my screen. Is that right? Can you all see that? Let me know. Can you see my screen now?
Yes.
Okay. All right, good. So this unit 3 will be include section 4.1 and then chapter 5. Chapter 5 will be from 5.1 to 5.4. Okay, so that is the one we're gonna cover tonight. Is the one section from 4.1 and then 5 section from chapter 5. 4 section from chapter 5. Okay, so totally actually it's 5 sections. All right. One section is 4.1. 4 section will be 5.1 to 5.4. Okay. So 4.1 is about a discrete probability distribution. So what is a discrete? As we mentioned that earlier in the first couple chapters, discrete is something you can count, right? You can count 1, 2, 3, 4, 5, something like that. Something you can count is called the discrete, that kind of thing, that way. All right. So that is the probability we're gonna talk about. Let's see, I meet some people in the class. Okay, so just make sure everyone got in. Okay, so discrete probability distribution, that means we need to be able to look at what is a discrete random variable and what is a continuous random variables. So 4.1 is about a discrete random variable or the discrete probability distribution. And then chapter 5, we're going to talk about the continuous probability, that kind of thing. All right. Just let me make sure everyone got in. It's a bit tricky when I okay, here you go. All right, so that is we still need to be able to find a mean variance standard deviation for the discrete probability distribution, and then find the expected value for the discrete probability distribution. So that is the objective for this section. All right. So when we have a random variable, we have a discrete random variable. We also have a continuous variable, right? So the discrete variable is something, you know, in a number line is just 1, 2, or 0. Okay, so that is either 0 or 1 or 2. So that is the discrete. Okay, and what is a continuous? Continuous between 0 and 1, and then that is the whole interval. So that is something like that. So it can be 0.002, can be 0.99, right? It's between 0 and 1. So you can have as many decimal points as possible. So that is called continuous. And I can add as many decimal points in here as possible, right? So that is still between 0 to 1. So that is called continuous, okay? That is continuous. And then this one is discrete, okay? You either 0 or 1 or 2. That's it. All right, so that is just a point on the number line. The continuous is an interval, okay, between 0 and 1. And how many numbers between 0 and 1? There's a lot, okay? You can have an infinite number between 0 and 1 because I can have a 0.001, I can have a 0.5, or I can have a 0.99, right? And I can add a number here again and again. So those are the continuous number in here, okay? All right, so the discrete number is, something we can count, right? Count a 0, 1, 2, 3, 4, 5, something like that you can count, all right? Continuous variable is kind of, in an interval is, you can have as many decimal points as possible as long as you have a device to measure it, okay? All right, so this section we're gonna talk is the discrete variable, all right? And if we did, okay, so discrete probability is always between 0 and 1, okay? We don't want the probability to be negative. So we say if the probability equal to 0, that means it's impossible, right? This is impossible to happen. If we have a probability equal to 1, so this is for sure, okay? It's gonna happen in here. So that is this one. And the sum of all the probability in one table add up together must be equal to 1. Okay, so that is a probability distribution. If it's not equal to 1, that means the table is not a probability distribution. So it can be if you have only 0.9 or if you have a 1.2, not exactly equal to 1. That means that is not a probability distribution. Okay, so those are a little bit concept which we need to know that first. All right, so if we let x be the random variable with a possible outcome, you have from x1, x2, all the way to xn, right? And we're gonna make a frequency distribution for each possible outcome. And then we're gonna find a sum for the frequency. That means we're gonna be able to find a probability at the very end, that kind of thing, okay? So look at this example in here. We can construct and graphing a discrete probability distribution, okay? So we have a score x, so how do I do the probability distribution? I have x right here, right? And then my frequency, y will be my frequency, right? So now we have a 1, we have a 2, 3, 4, 5, something like that, right? And then okay, so and then like I said, when I have a 1, my frequency is 24. Okay, so if I have um this is 10, and then this is 20, and then this is 30 in here, for example, right? So when I have a frequency, when my score equal to 1, my frequency is 24, so that would be somewhere right here. All right, so that's my frequency, okay? And then when I have a 2, this will be 33, all right? So this is 40, so 33 will be somewhere around somewhere right here, right? So I can drop a 9 in here, and then when I have a 42, and then I can graph this one right here, right? We can move up a little bit more, and then that is 42, okay, 42. And then when this is 4, this is 30, so 30 is about right here, okay? So that's 30 for the 4, okay? And then when this is 1, this is 21, so 21 will be somewhere right here. All right, so that is my frequency distribution for this table in here, okay? So you can see this frequency distribution is kind of, if I kind of drop a regression line, this is a kind of something going up, right? And then also coming down. So a little bit similar like a bell curve, okay? So we're gonna say this is kind of roughly symmetric, something like that. All right, approximately. Okay, so if you use the histogram, okay? So histogram is the bar graph without a gap, right? So this is the histogram. All right, so you can see the similar one in here. All right, so and then you calculate the probability. So how do you calculate this probability in here? Well, this probability is kind of like the percentage, right? So if I have this table and what is my probability? Well, you can copy this table in here, okay? And then we can make a little bit frequency calculation, okay? Um, uh, all right, so basically we add all of okay, so you have this frequency. You're gonna add a sum. The big sigma is the sum, right? So my sum here is um 150. Okay, so this is my probability or my percentage, basically. All right, so this is my percentage in here. All right, so 24 corresponding to how many percent? 24 divided by 150. Okay, so that is 0.16. I'll make it a little bit bigger. All right, so and then we add all these together. So that is my frequency distribution. Look at that. All my table add up together. This totally should be equal to 1, right? 1 is 100%, okay? So that is the percentage, or sometimes we call it probability. Okay, so that is this one right here. So that's why you have a, score 1, that's 0.16, right? So you have a score 1, that's 0.6, score 2, um, okay. So you have a score 1 is 0.16, score 2 is 0.22, so 0.28 for 3, 0.20. All right, this one, if you want to make it a little bit one more decimal point, you can do this one right here, okay? So that is 0.20, and then score 5 is 0.14, all right? So that is how you calculate the probability, right? So this probability is kind of like a percentage. You add all the frequency together, and then using this is kind of like the probability using F over N. All right, N is the sum of all these frequencies. You add all these together, okay, and that's 150. All right, so each probability you using each number divided by 150. All right, so that is how you calculate the probability in here. And this graph, if I do a little bit regression line, okay, so this graph a little bit something kind of going up and then coming down right here. All right, so we can see this is kind of roughly or approximately symmetric. Okay, not perfect, but it close enough that we can say it's approximately symmetric. That kind of thing in here. All right. So that is how you construct this probability distribution. Look at it. My X number is the integer, right? It's either 1, 2, 3, 4, or 5. Okay. If I say this is the number of the, and this is individual psychology administrator personality interval, a test for the passive aggressive, to these 150 employees, right? And then the 1, that means extremely passive, and 5 is extremely aggressive. Okay, score 3 indicated, kind of in the middle, basically. All right. So that is the giving this 5 score. So that is the probability distribution. And if we want to find the average, okay, so if we want to find the average, how do we find it? Okay, all right, so that is the mean, right? If we want to find the mean, okay, um, if we want to find the mean, how do we find the mean? Okay, that's another question later on. All right, so this one, just next example, we're gonna come back to find the mean in here, okay? But let's verify if this is a probability distribution table or not. So number of the day of run, you have a 0 run, 1 day, 2 days, 3 days. And one thing is if this is a probability distribution, this probability add up together should be exactly equal to 1. Okay, cannot be less than 1 or greater than 1. So if I make this paste in here, all right, so let's see if I paste this whole thing in here, do I add up together equal to 1? So let's sum this one to see what happens. Oh, that's exactly equal to 1, right? So that means this will be a probability distribution, right? Because my P is greater than equal to 0, less than equal to 1. All right, that means they are all positive, okay? No one is greater than 1, no one is less than 0. So that's condition number 1. Condition number 2, my sum of the P is exactly equal to 1. We just checked it earlier, all right? So that means this is a probability distribution table. Okay, let's look at this one right here. Is this a probability distribution table? Well, we have an X value is from 5 to 8, all right? And then each probability is all positive and less than 1, right? But you're gonna need to go to add all these probability together to see if it's equal to 1, okay? All right, so if I go to add these together, let's see. I have a 1.07, and that is the issue. Okay, if you have a 1.07, that means this one, the sum, we satisfy the false condition. This one satisfied. The second condition is not satisfied. This is not equal to 1. This is equal to 1.07. We just calculate. So that means no, this is not a probability distribution because it didn't satisfy the second condition. All right, any questions so far? Okay, let's look at this one right here. Is this a probability distribution? Well, if you look at this table, look at it. My P should be greater than or equal to 0 and less than or equal to 1. So that's the condition 1, right? Condition number 2, the sum has to be equal to 1. Okay, so if you look at this one, you have a negative 1 right here. This didn't satisfy the false condition already, so I don't really have to check the second one because this condition, this false condition is not met. So no, this is not a probability distribution. All right, so those are the basic things. Sometimes it might just test you this kind of simple concept. Okay, next thing here is we want to talk the mean, as I mentioned earlier. For that table, how do we find the mean? Okay, we have a 1 is very passive, 5 is very aggressive for those 150 people. And what is the average score? Okay, so mu is the mean. All right, so this mean for the discrete probability is you have to use x times, so this one sigma is the addition, right? This is addition. Addition is lower level than the multiplication. So you're gonna have to multiply x times p of x. You have to multiply each x times p of x first. All right, and then that's the first one is the multiplication. Okay, the second one here is the addition. All right, remember the PEMDAS, PEMDAS. All right, sometimes if you have a parenthesis, you have to go first, right? Exponent also higher order, go to the next, to the parenthesis. And then that's the multiplication, division, addition, subtraction. Addition, subtraction is lower level than the multiplication and division. All right, so sometimes the people this call, please excuse my dear Aunt Shara, right? Please, so that is, you know, all right, something like that, right? So this is PMDA is. All right, so that's the order of operation. Okay, order of operation. Okay, so if you have a parenthesis, you have to go first. You have to calculate first. If you have an exponent, you have to also have to calculate first before you do the multiplication and division. All right. If you have a multiplication and division, you also have to do that first before you do the addition and subtraction. Okay, so that's the order of operation. One thing I want to emphasize here is the M and D multiply and division. These two are called pairs. All right. So when you have pairs, it's first come, first serve. Okay, first come, first serve. So it doesn't have to be M first, D second. If a division come in front of the M, you have to do the division first. Okay. So using pandas, sometimes people just want to make a sentence that way. But basically, if you have so for example, if I have 18 divided by 3, right, times 2, and then plus 4. So which one do you do first? All right, give me a really quick answer. So give me 1 minute to type it in your chat to see what is the answer for this one. All right, give you a really quick basic math algebra review. All right, what is the answer for this one? Okay, let's see. Do we have an answer here? Okay, 16. Anyone else? Okay, 16 is the correct answer. All right. Let's see, because we just mentioned earlier, you need to do the yeah, 16. Okay, we got a couple of people say 16, so that's correct. We just said earlier, for the multiplication and division is a pair, first come, first serve, right? So you don't do the multiplication, you have to do these two first. Division and multiplication are pair. Whoever comes first, you do that first. So there's no parenthesis here, all right? So 18 divided by 3, you got 6. Okay. And then this for the multiplication and the addition, you have to do the multiplication first, all right? Because multiplication and division are higher order than the addition and subtraction. All right, so yes, so your final answer is 16, okay? So that means this formula, I don't really need a parenthesis because we have a multiplication here. So multiplication is a higher order. So you will need to multiply first. So step 1 is you multiply first, and then step 2, you add them together. All right. So sometimes the people add a parenthesis right here. It doesn't hurt, but it's not necessary. Okay. Some people, some of the book add another parenthesis outside here. That means say, oh yeah, you need to calculate parenthesis first. But this one is not necessary, okay? Even you add a parenthesis, it doesn't hurt for this one. But, this one, we know multiplication had to go first, okay? All right, so how do I find like the average for the table we talked about earlier? So we have this data value x, right? This is a probability. So you're gonna using the x times p of x. Okay, remember you have to multiply first. Multiply first. You have a 5 of the score, so you have to multiply all 5 numbers with each probability first. Okay, and then the mu is equal to, remember the mu is equal to the sigma x times p of x. So you multiply these first, each one multiply first, and then go to add them together. All right, so mu is the sum of x. Okay, so you have all these add up together, add all these together, and that is the bin in here. Okay. All right, so the bin, you can go ahead and add this together. If you go to add all of this together, this is about 2.94. Okay, 2.94 in here. Okay, so 2.94 is close to 3, right? So on average, that means on average, people are kind of in the middle, not too passive, not too aggressive, right? But we also have to deal with those, two extreme in here. Okay, so we actually have a 0.16 the probability a person will be really passive, right? And then 0.14 of the probability, or 14% of the probability, some people, people are very, very aggressive, right? But you can see like these three in the middle are the majority. Okay, so when you have an average 2.94, that means average people, most of the time they are not too aggressive or too passive, that kind of thing. Okay, so that is how you find a mean. We also know how to find a variance. Okay, so this is the formula to find a variance. So we just talked the order of operation earlier. So each data value need to minus the bin first and then square, right? So you have an exponent, so you have a parenthesis, you have to find a parenthesis first. Okay, you have to find a parenthesis first. That's the first step, right? Second, so the fourth step, you have to find a parenthesis. So x minus mu inside the parenthesis. Second one, you have to find the exponent. Okay, so exponent have to go second before you multiply. Okay, so parenthesis exponent, and then you multiply using the whole thing. Step 2, multiply p of x. You multiply. And then step 4, you add them together. Okay, so this one you will need to separate into 4 steps. All right, and the standard deviation, you just take the square root for this whole thing. That is a standard deviation. All right, so that is this one right here. So if I want to find a variance and the standard deviation for this one right here, okay, using this formula, remember using this formula in here. All right, so in order to use this formula, we need to use x. Okay, so I don't really need a frequency. I don't need a frequency for now because I already calculated this probability. Okay, this is a probability p of x. All right, so we need to using my x times p of x. Okay. All right, so x times p of x, we have 1 times 0.16. Okay, and then the rest will be all multiplied, and then I will add them together. Oh no, you have to square them first. Okay. Oh no, hold on. There's one more step here in the middle. Okay, I just missed up in here. Okay, we have to minus the bin. Okay, so mu was 2 point mu here. Remember we said the bin here is equal to 2.94. So I will need to calculate the step 1, x minus the mu. Okay, I'll just type this one, mu. So x, this is x, minus 2.94 minus the bin first. All right, and that is this one. And then my step 2, that's step 1, right? Do the parenthesis. And my step 2, I have to do the exponent. So you're gonna have x minus mu square. Okay, square first. All right, so each one, if you square, you're gonna become positive. Okay, negative square will become positive. All right. And then one thing is in Excel, as long as you set up the first one, you just drag this one, everything will be calculated, right? And then we're gonna using this whole thing. So let's step through it. This whole thing gonna need to multiply by the p of x. Okay, so we're gonna multiply p of x. All right. So I set up using the equal sign in Excel. Every time you want to calculate, you have to put an equal sign first. And then using this square, multiply the probability. All right. Okay, and then I drag the whole thing down. Okay, so that is my step 3. Okay, step 1, we find the parenthesis. Step 2, we find the exponent. Step 3, we find the product, the multiplication. Okay, and then we're gonna add all this together. So that's our last step here is the big sigma in here. All right, so that is my variance. Okay, that's my sigma square. If I want to find a standard deviation, I just take the square root for this one. Okay, square root is 1/2 of power. All right, so, and then I can just round to any decimal point I want, right? Or I need, if I just round to 2 decimal point, that'll be 1.26. Okay, and this one, if I round to 2 decimal point, that will be 1.62. So 1.62, this one is the variance. Okay, this one is the standard deviation. All right, you take the square root of the variance. So that is the standard deviation. Okay, so that is how you calculate this one right here. Look at it. Let me pull this one in here. Okay, so you have this x minus mu, and then it didn't show the rest of them. You have to have a square first, and then times p of x, right? And that is 1.61 whatever that, okay? So if we round to 4 decimal point, exactly the same, right? 1.6164, that's 4 decimal point. This one, if I round to 1 decimal point, we got the same answer. All right, so I round to 1 decimal point, I got 1.3. Okay, so that is the most data value default from the mean by no more than 1.3. So that's the standard deviation. Okay, so that is how you calculate the variance and the standard deviation for this called a discrete probability. Discrete probability, the one we just talked in here. Okay, so this discrete probability also used in one of the application called expected value. Okay, so what is the expected value? Actually, expected value is just the mean. It's just the mean for the random variable. So E of x is still equal to the mu, right? And what is the mu? Mu, we just said earlier, you have a x times P of x and then add them together. All right, so the expected value usually in a lottery ticket, most of the time using in a lottery ticket in here, right? So look at this one right here. This is an application for the mean is called the discrete variable is called the expected value. Okay, so a raffle 1,500 tickets are sold at $2 each for 4 prizes. Okay, the first prize you got 500, second prize you got 250, third prize 150, and fourth prize 75. So if you buy one ticket, what is the expected value, and how do you explain this expected value? Okay, so I'm sure how many of you ever buy the lottery ticket? Like a jackpot or Texas lottery, whatever. Did any one of you ever buy the lottery ticket? Give me a thumbs up, say yes. You can have a reaction right here. Look at the reaction right here. You have a thumb up, say yes. Someone said no, never buy the lottery ticket. No one buy the lottery ticket. All right. Okay. I bought a lottery ticket as well, but I don't try to buy all of them to win, right? If you're trying to buy all of the lottery ticket to win, you actually lose. Okay, so we're gonna explain that why. So sometimes we say, I did pull tabs okay, all right. So, okay. We said you need to pray responsibly, right? We don't want to pray like irresponsibly. Something is like a sport ticket, right? Now they have some people bidding on the sport, the game, those kind of things. So yeah, so you got a lot of things to bid on, but as long as you play responsibly, it's just something for fun, which is okay. All right, I'm not against that. Actually, one time I was having a class with a bunch of these the called elementary, the secondary, school teacher, right? And I said like they said the Texas lottery usually support like a school education, so they're all very excited after class. They said everyone gonna go to buy the ticket, right? All right. But when you buy the ticket, you don't try to buy them all to win, right? You buy them responsibly. So you might just buy one or two, something like that. Okay. Definitely not trying to buy all of them to win. We will do the math calculation and you will know why. Okay. All right. So we said earlier the expected value is equal to the mean. All right. And mean is the sigma of x times p of x. Okay. So for this one, the challenging part here is you have to set up your x value. You have to set up your p of x. Okay. So how do you set up your x value? Okay. So we have a price. Okay. So we have a price. We usually using the x value is using the gain. Okay. How much you gain? All right. So if you win a false ticket, if you win a false prize, if you win a false prize, do you have to pay $2 to buy the ticket? The answer is yes. So you actually gain $4.98. You do not gain 500. Is that right? Because you have to spend $2 to get a ticket. Okay, so this is you kind of net worth. You gain $4.98. All right, so if you want a second prize, okay, if you want a second prize, you got $2.50. Same thing, you have to buy the ticket. So this will be $2.48. So $2.48 is you net gain value. All right. And then very similar, if you have a $1.50, you actually gain, if you want a third price, $1.50, you actually gain. Remember, we're using this as a gain. All right, gain $1.48. If you have a 75 or something, you minus 2, so you actually gain 73. You gain $73. All right. How about if you do not win at all, what happened? Well, you're gonna just lose $2. Okay, we have a -2. You did not gain anything. You did not win anything. You will just lose $2 in here. Okay, so that is our x value. This is our setting at the x value. And then we're gonna go to look at the probability. So what is the probability of winning the false prize? What is the probability of winning the 500 prize? Well, we only have one ticket here. So that's 1 out of total ticket, 1 out of the 1,500, right? So this is called a classical probability. Okay, if you only have one false prize, if I have a 2 false prize, now I have a 2 over 1,500, but I only have a 1. Okay, this is a 4 prize for all these 4. So each one is only 1. Same thing, I only have a 1 second prize. So that's the probability of winning the second one, the probability of winning the third one, the probability of winning the fourth one. They are all the same. Okay, so you have an equal chance of winning one of these 4 prizes. The problem here is, how about the rest of the people? Well, we only have a 4 prize, right? And then we have a 4 prize. Okay, and then we sell what? 1,500 tickets. Okay, so how many of them not winning anything? How many of them will not win anything at all? Will be 1,500 minus 4, right? So that's 1,496. Look at it. So you have a 1,496 out of 1,500 chance that you do not win anything. All right, so that is how you set up this probability distribution. So that is the application for the bin. All right, so now we have this whole thing. We're gonna just go to add and multiply them together. Okay, so this will be x times p of x. So you have a 498 times 1 out of the 1500. Same thing as this one. This is 248 times this one. And then 148 times 1 out of the 1500. And then 73 times 1 out of the 1500. All right, this one will be negative 2 times 1496 over 1500. Okay, so now we're gonna go to add all of this together. Add all of this together. Okay, and then the final answer is our expected value E of x. Okay, or the bin. Okay, so the bin here, basically, I have a same denominator. Look at it, I have a 1500 as my denominator. So I have a 498 times 1. 498 times 1 is still 498, right? And then 248 times 1 is still 248. Okay, and then 148. And then plus 73. This one is negative, so you have to minus 2 times this one. 2 times 1496, and that's a big number. Okay, so you're gonna add all of this together and then divide by 1 by 0, 0. All right, so guess what? What is the final answer? Let me go ahead, just let me find the final answer from here. It will be a little bit quicker. Okay, so this final answer here is negative 1.35. Look at it. So this is the gain value for the x. This is each one the probability, right? So you're using each one times the x value times the probability. And then this is negative 2 times the probability. So you have a negative 1.35. Negative 1.35. So what does negative 1.35 mean? That means every time you buy a ticket, I usually tell people, so this is kind of like a donation, right? If you think every time you buy a $2 ticket, you're gonna lose $1 and 35 cents. It doesn't feel that good, right? That you lose. But I just tell people that you donate, right? Usually when you buy the lottery, you kind of contribute to something. Okay, so you donate like a dollar, $1.35 to the whatever the organization, whoever hosted the ticket that way. All right. So that's why you don't want to buy all the ticket in order to win, because if you buy all the ticket in order to win, you actually donate the most, right? So that is this one right here. So expected value is negative 1.35. All right, every $2 you purchase, you donate $1.35. So that means this organization, they only use 65 cents, right? They only use 65 cents to make up all this price in here. All right. So now you know how the organization making money that way, right? Same thing as lottery ticket. Okay. When we buy the lottery ticket, the millions of people purchase that, right? And then it seems the price is so high, but the probability of winning is so low, right? So the organization is still making money. All right. So that's how you do this discrete probability for this type of application. Okay, any questions? Any questions so far? Okay, so we kind of spent quite a bit in this section. So that's section 4.1. The good news is for this chapter, we only require this section. Okay, we only require this section in here. We're gonna go ahead and look at the 5.1. Okay, 5.1 is a normal probability distribution, and this one will be introduced the continuous variable. The 4.1 is the 4.1 there was the discrete variable, and 5.1 is the continuous variable. Okay, normal probability distribution, and this one is our major chapter for unit 3. All right. So we still need to be able to find a probability, finding the mean, and then finding the central limit theorem. Okay. So introduce the normal distribution and the standard deviation, standard normal distribution, and of course we will talk about mean and standard deviation as well. Okay. So continuous variable. So we said earlier, continuous variable, that means there's no discontinuous point, right? Between 0 and 3, there's an infinite number between 0 and 3. So you're using the interval. You don't use the dot in there. This is the whole interval. So this whole interval from here is 0 to 24, right? So if you think of 24 hours a day, how do you live for 24 hours? Well, you live every minute, every second, right? So that's how you spend your 24 hours. You cannot just say, "Hey, I'm going to live on the just 1 o'clock," and what does that mean? And then you live in 2 o'clock, and what happened between 1 and 2? Well, you have to survive in order to reach 2 o'clock. So you live every second, every minute, that kind of thing. All right. So the time is a continuous variable. Okay. All right, we use this one called the normal, the bear curve. All right, so it looks like a bear. Okay, so if everything looks like a bear, this will be called normal. Will be called a normal curve, or sometimes we just call it a bear curve. Okay, so remember this bear curve will never touch the x-axis. So if you draw for this kind of a bear curve, that is wrong. This is not a bear curve because the bear curve will never touch. This can go on and on indefinitely. All right, this can go into the both sides indefinitely. It just never cross the x-axis. Okay, so that is called a normal curve. All right, so the bell curve characteristic here is since it's symmetry, so you mean median mode, triple M actually is all in the middle. Okay, so they are all in the middle, and then the bell shape is symmetry. All right, so that means this depth is equal to the right. Okay, the total area under this bell curve is 1 or 100%. Okay, 100% and 1 is the same thing. All right, so that is this one. Total area under the normal curve is equal to 1. This normal curve will never touch the x-axis. All right, and you can extend the further and further down. Okay, so we're gonna make a friend with this bell curve because we're gonna use it a lot for the chapter and the next chapter. Okay, so remember the empirical rule. The empirical rule, we always talk the 1, 2, 3 standard deviation, right? If we have a mu plus minus 1 standard deviation, that's 68%. Mu plus minus 2 standard deviation is 95%. Plus minus 3 standard deviation, that's 99.7%. So those are the empirical rule. Okay, so this is called an inflection point. So what does the inflection point mean? That means this bell curve, this is a concave down, right? This is kind of concave down. And after this point, actually is kind of facing up. It's decreasing, but this is facing up. So that's called the inflection point in here. This is kind of facing down, and then after this point, this is facing up. This is concave up. All right. So that is called an inflection point. Happen in 1 standard deviation in here. Okay. This bell curve is also called a probability density function. Okay. This function we don't have to use the calculator to graph them. We just need to be able to draw by hand. Okay. There's a complicated computer model equation for that. But we just need to know this bell curve only affected by 2 things. One is the mean, one is the standard deviation. Okay, so if the mean and the standard deviation are the same, the 2 bell curves we are exactly the same. All right, we are exactly the same. But if you look at these 2 bell curves, these 2 look pretty much the same shape, right? The same shape, that means they have the same spread. Their standard deviation is the same. but they are resided in different x value. Look at it. This one, the bin in here, bin is always in the middle because it's bell curve. So bin is in the middle. This bin here is 3.5. This bin here is 1.5. Look at it. So it kind of will have a different bin in this one, even they look pretty much similar. All right, this one you also have a bin is 3.5, but you can tell this bell curve is kind of widely spread out. Okay, so this is have a higher standard deviation. So the higher the standard deviation is, the wider spread is going to be. All right, so that is the different type of the bell curve. Okay, so which one has a greater bin? Well, the bin here, look at the bin here is this one. The bin for the B here is 12, right? And the bin for the A here is 15. Okay, so apparently A has the greater bin in here. But on the other hand, B gonna have a bigger standard deviation because B spread it out much bigger. Okay, B is spread out much bigger, so B gonna have a bigger standard deviation. Okay, so since this we talk about continuous data, so variables, so sometimes our data number might not be exactly 1 or 2 or 3 standard deviation away. So if it's not exactly 1, 2, or 3, what do? We're using a G-score, okay? We calculate the G-score, and then we're gonna be able to read the table to see how many percent is there, or what's the probability is there. All right, so the G-score is using the data value minus the mean divided by the standard deviation. I think we should calculate this one a little bit earlier. I guess, that kind of thing. All right, so where's the standard one? Where's the standard normal distribution? Standard normal distribution here is mean is always 0. Mu here is 0. Okay, and the standard deviation will be 1. So that is a standard one. Okay, so if we change all the data value into the standard one, we will be able to read the table. Okay, all right, so the table is using the G-score. Okay, so the probability of the standard normal distribution is you can convert this whole thing into called the G-score. Okay, the G-score here, the G-score in the middle, G-score in the middle is 0. Going to the right, G-score will be positive. Going to the left, G-score will be negative. All right. So so that means we will learn how to read the G-score table. Okay. Since this area is 1 or 100%, and the bell curve is symmetric, right? So the left side and the right side will be equal. Each side will be 0.5. Okay. All right, so this one is reading the table. How do we read a G-score 1.15? What is a G-score? So that means we will need to learn how to read a table from this chapter. Okay, and the table actually is very straightforward. So let's see, we have a table. I think I also posted this table on the, I mean, you can find this one on your step, my step there. But I think I also posted on the, download the whole thing, posted on the Canvas. Okay, so first, before you read this one, you have to know this is called a key or the legend in here, right? This is called a key. All right, or the legend in here. This don't let me write. Okay, so that is the key or the legend. So this one means this is the area to the left. All right. So whatever your G-score is means area to the left. Okay. So if we have a positive 1.25, okay, let's see. If I have a positive 1.25, so I have to go to the positive one, right? And I go to the top one. So that is the top one for the 0.5. So this one will be z-score equal to 1.25. All right, so if I have a z-score is 1.25, my area to the left will be 0.8944. So this is my z-score. If this z-score is z-score is 1.25, right? And then that is the area. So this whole area to the left will be 0.8944. So that means this will occupy about 89.44% of the entire area. Okay. But if I have my z-score is negative 1.25, so I need to come here to look at my negative 1.2, and then I have a 5 on the top. All right, so that would be 0.1056. Okay, so if I have a z-score equal to negative 1.25, this will be just this small area. Remember, the z-score area is always corresponding to the depth, area to the depth. Okay. All right, so look at this one right here. This one z-score is 1.15. So you go to the 1.1 on the left, and then look at the 0.05 on the top. So that is 0.8749. Okay, so that's the area to the left. This one is negative 0.24. So you go to look at the negative 0.2 and then look at the 4 in here. So the area to the left will be 0.4052. Okay. All right. So finding the area under the normal bell curve is always the area to the left. Okay, or area to the left. And sometimes the people say, well, since the table only point the area to the left, how about if I want to find my area to the right here? How about if I want to find this area? Well, unfortunately, the area to the right, we don't have a table to do it. But we know the total area is 1. So you just using 1 minus the area to the left. Okay, area to the left is 0.8907. So this is subtract, this will be 3901. Okay, so this area to the left here. So this area to the right here is 0.1093 because my 0 to the left is 0.8907. So these two added together should be equal to 1. Or if you want to find the area to the right, you just subtract area from the left, subtract from 1. Okay, so that will give you the area to the right. Okay, how about if you want to find the area in the middle, just like this one? This you want to find the area between these two z-score. So you have find the area. Area is also the probability in a bell curve. So z-score will be greater than negative 0.75 and then less than 1.233. So we're gonna go to read the 2 z-score area. If you read the 1.23 is area from here all the way to the left, right? If you read the z-score is 0.75 is the area from here all the way to the left. So if you're using the bigger area minus the smaller area is exactly the area in the middle or the blue one. Okay, so I'm going to using the probability of z equal to 1.3 minus the area or the probability of z equal to 0.75. It's not using this number minus this number. It's using the area. Okay, the area in a bell curve is also the probability. So you're gonna have to go to read the table first. So 1.23, I think we read it a little bit earlier. Let's read it again. 1.23 is positive, right? Positive 1.23. Okay, we have 1.25 earlier, 1.23 right here. Okay, so that's 1.23.8907. Okay, and then we're gonna go to look at the area to the left, which z-score is negative 0.75. Okay, so we're gonna have to go up, go to the negative 0.7, 0.7 right here. Okay, 0.75 in the middle right here. Okay, so that area is 0.2266. All right, so the area is 0.2266. And then you're gonna just go to subtract these two. Okay, so if you subtract these two, let's see, what do you get? This will giving you 0.6641. Okay, so that means this area in the middle is 0.6641. All right, so that is the three situation, right? First situation, if you want to find the area or the probability to the left, you just read the table. Second situation is if you want to find the area to the right, you just using 1 minus the area to the left. Okay, this is the third one. If you want to find the area in the between, in the middle, you will need to using the bigger area minus the smaller area. All right, any questions? So that is our 5.1 already. Okay, this is a 5.1. All right, I want to go ahead, as we said earlier, we're gonna introduce all the 5.1 to 5.4. Okay, so 5.2 is finding the probability. All right, so how do we find the probability for the normal distributed variable using the table and using the technology? All right, so this chapter actually, when people talk finding the probability in this chapter, actually is very straightforward, right? Every time you need to find a probability, guess what? You want to find a probability, you will need to go to know the G-score. Okay, so first you have to have a G-score. Second, read the table. All right, read the table, and that's how you find a probability. So this chapter finding probability is very, very straightforward. Okay, you just need a little bit calculation and then read the table, and then you got a probability right away. All right. So look at this one right here. If this is a random variable, x is normally distributed. You want to find a probability that x will fall in a given interval by calculating the area under the normal curve for the interval. Okay, so you want to find a probability for x is less than 600. All right, this is area to the left. Okay, area to the left. All right, this whole area to the left. Okay, so I know the mu, I know the sigma, I know the data value is 600. So I will need to calculate my G-score. G-score is x minus mu over sigma. So my data value is 600 minus my mean, 500. Okay, my standard deviation is 100. So if you go to subtract that one, is 100 over 100. So G-score is equal to 1. 1 you can also write down as 1.00, because when you go to read the table, it has 2 decimal points. Okay, so let's see. 1.00 is positive. Okay, so I have a 1.0 right here, and then look at that. This is 0, 0. So 1.00 is this one. It's 0.8413. So probability of x less than 600 is equal to the probability of G-score less than 1.00. Okay, I convert the x value into G-score. So this value here, we just read it earlier. All right, 1.00, so it's 0.8413. All right, so or you can write down at 84.13%. Okay, so the probability of selecting a number less than 600 is 84.13%. Or you just say 0.8413. Okay, any questions? Anyone has any questions?
Yes, I have a question. Where can we find the table that you are projecting?
Okay, so this table actually is on the e-text. It should have on the e-text, but if you cannot find it from your textbook, I can post it from the I can post that from the I can post that on the Canvas basically. I can download and post it on Canvas because this one I download this one from the book, the ebook.
Oh, okay. Yeah, thank you.
Yeah.
I would appreciate it.
Okay, no problem. I can just post this one I already download. If you cannot find it, I can just post this page, the whole table. You know, there's 4 pages here. Yeah, I can just post it on the Canvas, so that way you don't have to go to find it.
Thank you very much.
You're welcome. All right, so let's look at another example. Okay, this chapter is finding the probability. Okay, chapter 4 is the discrete probability. Chapter 5 is the continuum variable probability, that's why we use the bell curve. All right, so bell curve is very straightforward, in my opinion. All right, so if you want to find the probability, step 1 you have to find the what z-score. Step 2 you have to read the what table, and then step 3 you got a probability. So you just have to know is this area. So the probability is the area. Okay, it's the bell curve area. All right. So you're gonna need to look at is the area to the left or area to the right or the area in between. Okay, so you just have to identify which part of the area you're looking for. And you have to read the question very carefully. Okay, so let's look at this one. National study found that college student with job or work average of the 22 hours per week. Okay, standard deviation is 9 hours. So a college student with a job is selected at random. So let's choose one college student only. We're gonna talk a little bit more later on, but right now it's all using one. Okay, so we want to find a probability that a student work for less than 4 hours per week. Assume that the length of the time college student work are normally distributed and can be represented by the variable x. So normally distributed, that means it's a bell curve, right? Or even it's an approximate normal distribute, we can still treat as a bell curve to do the calculation. So I like to draw a little bit bell curve. Okay, and then I write down everything I have from the question. My mean here is 22, average is 22 hours. Okay, my standard deviation here is 9 hours. And I want to find a student that work less than 4 hours. So 4 is less than 22, so it should be on the left side. All right, less than 4 hours. What does less than mean? That means the area to the left. Okay, if you have an area to the right, it's greater than 4 hours. So this is area to the left. So this is area to the left. Okay, so what does the area to the left mean? That means I only need to read the z-score. My z-score, go to read the z-score table. Z-score table, the area will be the final answer. I don't have to add or subtract, that kind of thing. Okay, so step 1, you have to find the z-score. My z-score is x minus mu over sigma. All right, my x here is 4. Look at that. 4 minus the mean. That's why I like to write down everything there so I don't have to go back to the question again. And then divided by this one will be 9. Okay, so this will be negative 18 divided by 9 or negative 2. Negative 2, you can think it's negative 2.00, right? So now I go to read the table. Okay, my z-score here is negative 2 or negative 2.00. So I have an area to the left. So when I go to read the score, that will be area to the left. So my area or the probability that the x will be less than 4. Let's see what do we get. 2.00 or negative 2 right here, negative 2. Look at that, this kind of change. Look at that, the negative one is start with its 0.09. So my negative 2.00 actually is the last one. not that one right here. It's this one, not this one. Okay, not that one. Remember, I have to read the top as well. And then if you look at the positive one, positive, when G starts stay positive, this is actually 0, 0 is right here. Okay, when G is negative, 0, 0 actually is on the last one. All right, so that's why you always read it very carefully. Don't assume. Okay. All right, so I have a negative 2.00. That is 0.0228. Okay, 0.0228. If I change it into percentages, so that means 2.28%. All right, so a little bit less than 3%. Okay, so apparently a lot of students have to work, right? Just like that's why we have weekend college in here. All right, only less than, I would say less than 3%, right? 2 point, it's just round to one decimal.
Yes. Like, it was fine. Like, it was normal.
All right, so only 2.3% of the people work less than 4 hours per week. So what does the majority of people mean? That means quite majority on 90, quite a bit of the people work more than 4 hours a week. Okay, so that is how you do this one.
You want to come here and check it out?
Oh, I'm sorry. Can you mute your speaker? If you are not, if
Because it
you
was
are not,
registering way too hot for the temperature that I set it at. It was like going up, like rapidly. There was no smoke forming.
Yeah,
Kimberly, can you mute
was on a shutdown cycle. What happened?
I shut it down.
Okay.
Hold on,
I
hold
felt like it was
on.
going way above what it was the temperature supposed to be.
Hold on, Jeff.
Okay, we need someone to mute the.
Yeah, because I don't want this to set
Kathleen, can you mute your speaker? Kathleen, can you mute your speaker? Yeah, because we cannot.
I just muted her, Professor. There was a way to do so.
Oh, okay, good. Thank you.
You're welcome.
Yeah. All right. Because we have so many, we cannot. I got too many screens right here in here. So thank you. Yeah. So that is this one right here. So we need to identify which area we're looking for. So if you have a less than is area to the left. And then if you have a more than, okay. So what does more than mean? More than is greater than, right? So greater than will be area to the right. Okay. So if this is 4, this is more than 4 will be area to the right. Okay. So that should be really easy to identify that way. But if you have a less than is area to the left. All right. So that is how you calculate this kind of probability. So in my opinion, as long as you identify the area correctly, this probability should be pretty straightforward. Okay. So that is our 5.1. And of course, you need to know how to read the table. Okay. Any questions about this section for now? Okay, if not, we're gonna move on to, we have a 2 more actually. We have that's 5.1. We also have a 5.2. Oh, that is a 5.2. Okay, good. So that's 5.2. So we have 2 more sections to go. All right, 5.3. Okay, I know this is kind of a accelerate course, so we have to cover quite a bit in one week. All right. So 5.3 is finding the data value. So basically, we're still using the same formula, right? Look at that. We have a z-score equal to x minus mu over sigma. So if I giving you the x value, if I giving you the x, giving the mu, giving you the sigma, you can find the z-score, okay? And then this section here is you want to find a value. So that means if I'm giving you the z-score, can you find the x value? So the answer will be yes. So the good thing is in the table, we also have a x formula. Okay, so you multiply both sides by sigma, and then you have x minus mu, right? And then you add a mu on both sides. So that is the x formula for that. So that means if I'm giving you the mu, giving you the z, giving you the sigma, you should be able to find the x. All right, so that's called finding the value in here. Okay. If you look at the formula, the table include a formula. Let's see. This is only the table. You still have a formula as well. Okay, I'll find out the formula sheet and I'll post all together. So the good news is this formula is also in the formula sheet, so you don't really have to solve for x. You can just graph and use that. All right, so that's finding the data value in here. Okay, transfer the z-score into the x value. Okay, so you're gonna need to find the z-score from the table. All right, so you giving you the z-score, you're gonna need to find the data value basically in here. But sometimes the z-score is given in a different form. Okay, if we're giving you the probability, so remember in the bell curve, the area is also the probability. All right, so if I'm giving you a area is 0.3632, can you find a z-score? Can you find a z-score? So basically, this is called reading the table backward. So what does reading the table backward mean? That means I'm giving you the area. You need to find a z-score. Okay, we just learn a forward, right? Forward is always easier. So I'm giving you the 0.32, and then if I'm giving you the 0.32, 0.3 right here, 0.32 right here, right? So we can read the z-score right away. But this question here is if I giving you the this data value, can you find so for example, I'm gonna giving you this probability is 0.8907. Can you find a z-score? Oh, the answer is yes, right? If I'm giving you this one right here, now the z-score, you can go to find, oh yeah, this is 1.2, and then that's 3, so that's 1.23. Okay, so a little bit backward reading in here. Okay, so sometimes reading backward will be a little bit challenging. So sometimes I also like to use a calculator. All right, that's 0.3632. So that's 0.3632. So if I go here, so where's my 0.3632? Well, look at this one right here. It's too small, right? And then this one is too big. So 3632 should be somewhere right here in the middle. So I go to find 3632 right here. Look at that, right here. Okay. All right, so you can just kind of eyebrows in here. And then the 0.3632, that is negative 0.3, and then go up here. So it's negative 0.35. Okay, so that is how you read the table backward, negative 0.35. All right. Sometimes you don't find the exact value on the table, and that is a little bit challenging in here. So if you don't have an exact value in the table, you're gonna have to estimate. So instead of a 0.3632, if I have a 0.3631, now what happened? Now I go to look at this one right here. Oh, this is too small, right? And then this is too big. So now what do I do in here? 0.3631. So you're gonna go to look at 0.36.31. Actually, it's very close to this number. So you're gonna go to look at one is less, one is bigger, and then trying to see which one is closer. And then you use this one. So this z-score will be estimated into 0.35 as well. Okay, if you don't find the exact answer. And sometimes they can be a little bit challenging because, that's why I like to use the calculator to find the Z-score backward because it's much easier, okay? All right, look at this one right here. I want to find a Z-score. They have a 10.75% of distribution to the right. So 10.75, that means this percent is divided by 100, right? Divided by 100, so that means you have to move to the left for 2 digits, moving to the left for 2 digit decimal point. So that's the area is 0.1075. But remember, my Z-score is always the area to the left. So I will need to go to find my area to the left first before I can go to the table to find this Z-score. Okay, so remember the total area is 1. So I am going to using 1 minus this 1. So that's 5, that's 2, 9. So, oh. All right, so that is 9. Oh, that's 1 right here. So that should be 8. All right, so that's 0.8925. Okay, so that's 0.892. You can use a calculator if you need to. All right, I just didn't open a calculator, trying to do that by hand. Okay, so that is the area to the left. So when you go to using this table, so you're gonna go to read a 0.89. You're gonna go to okay, you're gonna 0.8925. So you're gonna go to find a 0.8925. Okay, so 8925. 8925. So you can see 8925 somewhere like 8925 right here. All right, so that's 8925. So that's 1.24, 1.24 right here. Okay, so that is 1.24. That is your Z-score. All right. Okay, let me show you how to use the calculator to find a Z-score backward, because sometimes if you don't find the exact answer, you don't have an exact value, it's very hard to find. So if I go to second bar, which is the distribution, okay, and I am going to using a normal PDF, okay. Now this second bars is the distribution using the inverse norm. Yeah, inverse norm, because we want to find a Z-score. So find a Z-score, you can using the inverse norm. All right, inverse norm, and I hit enter, and you just input the area. Okay, so my area here is actually, my calculator is a newer version, so it has an area to the left, to the right, or in the center. If you have this kind of calculator, okay, let me show you another type of calculator, which you don't have a. If we use a little bit older version of the calculator, it still works. It just doesn't have a TI-83 Pro. Okay, let me show you this one right here. Okay, I'm trying to find some of them. Okay, that one I couldn't open right now. All right, so if you don't have some of the calculator do not have a left, center, and a right, the default is always on the left. Okay, the default is always on the left. So that's why you always have to, if you don't have a calculator, if you have a little bit older version of the TI-84, it doesn't have a left, center, and a right. So you always have to calculate the area to the left. Okay, because that's the default. This one, I calculate the area to the left here is 0.8925, right? 0.8925. Okay, and the default is to the left. And then we want to put this into standard G-score. So, the standard normal distribution. So you just paste there. Okay, and then hit enter. So you run to 2 decimal point. This calculator giving you a lot of decimal point, but we just run to 2 decimal point, match the table. So that would be 1.24. Okay, and then look at this one right here. Since I have since my calculator is a little bit newer version, so I have an area. If I using this one, using this bell curve, this is area to the right, 1075. So I can also using point I can also using 0.1075, and I just need to point out, say this is the area to the right, okay? And I don't have to calculate area to the left. And this we are giving you the same answer. Look at it. These two answers are exactly the same, right? So I have this inverse norm, which is finding the G-score. So I have this 0.8925. This is the area to the left. All right. But since I have a newer version of the calculator, so I can have just type of area to the right. So I have this one right here. Okay. So that's a good thing with this newer version is you can point out area in the center or in the left or in the right, that kind of thing. Okay. If you don't show this one right here, the default is always area to the left. Okay, so you have to make sure you have a area to the left before you find the G-score. All right. The same thing as reading the table. If you want to read the table, you also have to calculate the area to the left. Okay, and then find the G-score. All right, so look at this one right here. If you have a 5 percentile, okay, so what does a 5 percentile mean? 5 percentile, that means it's area to the left, okay? 5 percentile, area to the left, 5%. All right, so sometimes people in the homework did not know how to calculate 5 percentile. This is a 5 percentile. Okay, 5 percentile is the area to the left. So that is 5 divided by 100. So you move 2 decimal point from here. Okay, so that's 0.05. So if you go to use this one, 0.05 area to the left, right? And then this one, since if you go to read a table, it's very hard to read a table because G-score gonna be exactly in the middle. So look at it. I have a 0.05. So where's 0.05? Well, 0.05 somewhere right here, right? Look at this one. This one is too small. And then look at this one right here. Right, I'm going to delete all this so you don't get distracted. Okay, so look at this one right here. My area is 0.05, and I cannot have a number exactly in the middle, say 0.050, right? 0.05. So this number 0.05 is exactly in the middle of these two numbers. Okay, so that means you cannot either choose this one or choose this one. So now there's no one is closer. So what do? Now you have to use the negative 1.65 plus negative 1.64 divided by 2. So you have to do the average for these 2 points. Okay, that's how you come out with negative 1.645. Because you have to take a negative 1.64 plus negative 1.65 and then divide it by 2. Okay, that will give you negative 1.645. All right, so that calculation can be sometimes a little bit challenging. But if I go to the calculator, okay, just show you one more time, how do you find this inverse norm? Go to second bar is a distribution. Number 3, inverse norm, that's inverse, that's finding the G-score, okay? And then I have an area is 0.05, and that's area to the left, that's right, okay? And then I hit enter. look at it. If I run to 3 decimal point, okay, so negative 1.645, this will run up, right? Exactly the same. All right, so that we are giving you much easier to find a Z-score by using the calculator. All right, how do you find a 90 percentile? Well, 90 percentile, that means the area to the left is 90%. Okay, area to the left is 0.9. All right, you can you can add 3 more zero, that's fine. So that's 90 percentile. But if you go to read a table, it didn't have a 0.900. The closest number here is 0.8997. Okay, let's look at the 0.9. Look at it. I have this one, I have that one. Okay, which one do you choose? We choose the closest one, right? So if I choose this one, it only have a 0.003 different. If I choose this one, it's gonna have a 0.0015 different. So apparently 0.9, we are closer to this one. We are closer to this one. So that's why we choose this one instead of that one. That way. So that's 1.28, 1.28. All right, that's how you get a 1.28. If I'm tired of calculating all these, I just put it in a calculator. Okay, that's why I like to use the calculator to find. Oh, hold on. All right, second bar distribution. Go to the inverse norm, and I just say 0.9, 90 percentile, 0.9. Okay, I don't have to input that many decimal point. Okay, so I run to 2 decimal point. So I run to 2 decimal point is 1.28, right? So this calculator Z-score actually is more accurate because in a table we cannot show that many decimal point. All right, so we usually just only run to 2 decimal point for the calculation. Okay, so what do we do with all this calculation? Look at it. This one you want to find look at this one right here. Finding a specific data value for a given probability. Okay, so that is kind of a little bit like an application. All right, the score for the California piece of is a standard and trending test are normally distributed. So that means that's a bell curve, right? With the mean is 50, standard deviation is 10. And agency, we only hire applicants with the score in the top 10%. All right, only hire the top 10%. Now you need to know what the top 10% mean. Top 10% is the highest 10% is the area to the right. Okay, so that's the top 10%. Top 10%. If we set the bottom 10%, lower 10% will be area to the right. Okay, that's the bottom 10%. That's the area to the left. All right. Since this one is set the top 10%, so must be area to the right. Okay. What's the lowest score? What is the lowest score that you can earn and still be eligible to be hired by the agency? So apparently this want to find a data value. And the data value is mu plus z times sigma. Okay. And then we have the mu, the mean here is 50. Okay. Z-score, I do not know, but I do have a standard deviation is 10. So that means that as long as I can find a Z-score, I will be able to calculate this data value, the lowest test score. Okay, so Z-score connect with the percentage of the probability. So I have a top 10%. Okay, top 10%, you need to go to find a Z-score. This Z-score corresponding is 1.28. And you will wonder why this is 1.28, right? You can use a calculator to find them. You can find the area to the right if you have a newer version of the calculator, or you can just simply calculate this area to the left will be 0.9, right? This is 0.1. So area to the left will be 0.9. So we just look at this one earlier. Look at it, 0.9. If you have an area to the left, 0.9, my Z-score here is 1.28. All right, so I will just use 1.28, plug it in, 1.28 times 10. So 1.28 times 10 is 12.8, right? So that's 62.8. If you round to the integer, that means it's 63. Okay, so that means in order to score in the top 10%, your lowest score must be 63. All right, and if you test a score in a 63, you will be still eligible on the top 10%. Of course, if you got higher score, it's better, right? But this is the lowest one, the lowest score that you can still be qualified as a top 10% and getting higher. All right, so that is this section, which is called finding the data value 5.3 section. Any questions? Anyone has any question about this one? Okay, one more section to go for the last section. Okay, basically the last section is very similar to the previous one, but when we talk the previous section, we always sample 1. Okay, n is always equal to 1. When n is not equal to 1, n usually is, when n is greater than 1, we have one called the central limit theorem. All right, so that is the last section, sampling distribution and the central limit theorem. All right, so that means, in short, that means you can sample more than 1. All right, so if you take a 2 or 3 or 10 at one time, now you have this sample is n is greater than 1, right? If your n is greater than 1, your sample mean is still equal to the population mean. That's what I mean in here. Sigma of the x bar, okay, so if, like I said, if my n equal to 4, okay, so I take a 4 as a sample every time I take a 4. So this sample mean is still equal to the population mean. But since your sample size increases, so your standard deviation will decrease. So why is it decrease? Because n is greater than 1, so your sigma x bar gonna be less than sigma, okay? Because you're gonna divide by a number that is greater than 1. So this one is called the standard error of the mean, okay? The sigma of the x bar is called the standard error of the mean in here. So the only thing difference here is when you do the sigma, you must divide by the square root of n, okay? You must divide by square root of n in here. So that is called a central limit theorem. All right, so what happened in this calculation? Well, this calculation, when you come to the z-score, when you do the z-score, right, z-score, if we have n equal to 1, my z-score will be just x bar minus mu over sigma. But if my n, like I said, if my n equal to 4, what happened? Now this mu become mu of the x bar, right? Sample mean. And then this sigma becomes sigma of the x bar. So sample mean is still equal to the population mean, but I just choose this one divided by square root of n. Okay. One thing is if you type this whole thing into the calculator at once, you need a parenthesis for both top and down. All right. You need a parenthesis, very, very important. If you don't have a parenthesis for either one of these, you're gonna get a wrong answer. So even the denominator still need a parenthesis. Okay. All right, so let's do this one more question. This is the last question for tonight. Okay. Finding the probability for sampling distribution. The bin room and board expense per year at 4 years is $10,453. You randomly select 9 colleges, not just one, but you randomly select. So your n here is 9, your n here is not just equal to 1. Okay. What is the probability that the bin room and board is less than this amount? Assume these are normally distributed, okay, with a standard deviation is this much. Okay, so what are we looking for? We're looking for the probability in this chapter. And remember, probability in this chapter, you have to find a z-score. Second one, you go to read the table. Okay. And then number 3, you identify the P. Okay, you identify. All right. So either area to the left, to the right, or in the middle. Okay, so this one is a dash them. Dash them will be area to the left. Area to the left. Dash them. Think a dash them is left. All right. So if I draw a little bit of bell curve, okay, if I draw a little bit bell curve, my mean here, my mu here, I like to write down everything so I don't have to go back, right? My mu here is 10, 4, 5, 3. My standard deviation here is 1650. This time I need to write down n. N is 9 because n is not 1. Okay, and then my data value is 10750. So a little bit greater than this one, so must be on the right. 10750. Okay, we want to say, what is the probability that you randomly select 9 and the room and ball will be less than. So less than is area to the left. All right. So basically, I got everything ready. I am going to find my z-score. Okay, I'm going to find my z-score will be x minus mu over sigma divided by square root of n. Remember, when n equal to 1, square root of 1 is 1, right? So you have a sigma divided by square root of n, it's just n is 1, so this is still equal to sigma. So that's why when n equal to 1, we don't have to write down square root of n. All right, but now n is not equal to 1, so you must write down in here. Okay, all right, so we have a x, we have a x, it's 10,750 minus mu is 10,453, okay? Sigma is 1,650 divided by square root of n is 9. Remember, I mentioned earlier, I emphasized earlier, very, very important. If you want to calculate everything together, you must use the parentheses. If you don't use the parentheses, your answer gonna be wrong, okay? Include a denominator, all right? So let's see how do we type this one into the calculator, okay? Let's do it step by step in here. Even using a calculator is still very important, right? Because if you don't get a calculator right, you never get a correct answer. So remember parentheses, 10,750 minus 10,453. All right, parentheses. And then divided by, since my denominator also got 2 numbers, so anytime when you have a 2 numbers, you need a parenthesis. Okay, so 1,650 divided by square root of 9. If you know square root of 9 equal to 3, you can just type a 3 here, right? But if you do not know, just go to second x squared, that's the square root. Okay, anytime you need to hit a blue button, you have a blue button, you have to hit second first. All right, and then make sure you cursor up before you close the parenthesis. Okay, so you have a parenthesis on the numerator, you also need a parenthesis on the denominator, and hit enter. All right, that is the correct answer. So your z-score here is 0.54. Your z-score here is positive 0.54. Since I'm reading the area to the left, so my x less than 10,750 is equal to my z-score is less than 0.54, right? We converted this data value into the standard score. Now we can read a table, okay? So I'm going to read my table. Reading forward is very easy. All right, let me go ahead and delete all this so you don't get confused. All right, so 0.5 right here. Okay, so we have a 0.5 right here, 0.04 right here, so that will be right here. Okay, so 0.54, this reading forward, just read the table, very easy. So you have a 0.7054, 0.7, 0.7054, or if you convert it into percentage, right? So that would be 70.5% of the change. So if you randomly select 4-year colleges, the lumen ball less than 10,750 will be 70.54% of the chance. Okay, I'm gonna use the same question, but if I change n equal to 1, everything else is the same. What happened? Well, my z-score will be just x minus mu over sigma, right? If my n equal to 1 in here. Okay, so this will be 1650. All right, let's see what happened with this z-score. All right, so I still need a parenthesis on the numerator. Oh, hold on. It didn't take a mind. Okay, divided by 1650. I don't need a parenthesis for the denominator because it's only one number. I need a parenthesis is when it has two numbers. Okay, so my z-score here is become 0.18. All right, my z-score is 0.18. All right, let's see what is the probability. Let's see if the probability for g is less than 0.18. Okay, so 0.18, 0.1 right here, right? 0.18 will be right here, 0.5714. Or 57.4% of the chance. So you can tell from this one right here, if you randomly just select one 4-year colleges, the probability will be less than $10,750 will be 57.14% of the chance. All right. So, but if you randomly select 9 colleges at a time, your probability basically increase in here. All right, so this one, I just want to let you compare when n equal to 1 and n is greater than 1. How did it affect the outcome in here? Okay, so that is pretty much this chapter. We just finished. This is 5.4, the entire chapter. All right, any questions? Okay, I'm going to stop recording. So if you have any question, you can still ask.